Welcome to the next video. In this video, we'll be solving another previous year problem by KTU. This was asked in 2017 January for 10 marks. This is from MOS semester 3 for civil engineering. This is from module 5, and in module 5 it is from the column portion of the module 5. Okay, so the question here it is asking us to find buckling load. So what is given? Hollow alloy tube 5 meter long and diameter 40 mm and 25 mm. So it's a hollow tube with diameters 40 mm and 25 mm. It is found to extend 6.4 mm under tensile load of 60 kN. Find the buckling load of the tube when used as a strut with both ends pinned. Okay, so here it is clear that we have to use Euler's buckling load. So Euler's buckling load, the formula is given by pi square E I upon LE square. Okay, L is effective length, E is the Young's modulus, I is the moment of inertia, P is the buckling load. Now, what is given? The dimension is given. So it's a hollow cylinder, hollow tube. 40 and 25 mm are the diameter. So 40 mm is the outer diameter. So I'll call that as capital D. 40 mm. Internal diameter is 25 mm. So this I will call as lowercase d. Okay, and some other information is given. Now this information is just to confuse you. Now what is this information? It is not confuse you. You have to use the information. Now you see what all. So once you know diameters, you can find the value of I. Okay, how I equal to given as I is for hollow tube. The I value is pi upon 64 into capital D raised to 4 minus small d raised to 4. Okay, so that means these two values we have. So that means the value of I we can find. Pi is a constant. LE we can find. Let's see how we can find LE. It is telling that 5 meter is the length, and what is the boundary condition? Let's see, is there any boundary condition given? So the column is there. The length of the column is both ends pinned. So both ends pinned means it is both end is a pinned condition, boundary condition. So this is there. The length is given as 5 meters. Okay, the moment you see the length and boundary condition, you can find the effective length. Effective length in pinned case is same as the length. So that is, it is also same as 5 meter. So I have effective length. We have pi constant. I we can calculate. LE is there. Now E is not given. Now E is not given. For calculating E, some other data is given. So what they're telling is when we are applying the load, when we are applying an axial load of 60 on the column, okay, 60 kilonewton, the change in length is coming out to be 6.4 mm. Okay, so this we have to use the module 1 concept here. If there is an axial force on a member, how do you find the elongation? Okay, so this we can find by delta L is given upon PL upon AE. Okay, so in this P is given, length is given, area we can be calculated from the cross section. E we don't know, delta L is given. So from this we can find the value of E. E is nothing but PL upon A into delta L. Now what is the value of P? P is nothing but 60 kilonewton. So 60 into 1000 Newton. Okay, what is the value of L? The original length you have to take, not effective length. Now here both are same, so no confusion there. It is 5000 mm. Okay, PL. Now area, you have to calculate the area. So pi by 4 into d square minus d square. So we just calculate this very fast here. So it is pi by 4 times capital D is 40. Small d is 25. So this gives me 765.8 mm square. 765.8 mm square. Okay, so we have the values. Now delta L is also given. What is the value of delta L given? Delta L is given as 6.4 mm. Now when you substitute this, we can find the value of E. E is 60 times 1000 times 5000 divided by 765.8 times delta L is 6.4. So when we calculate this, let's see what value we will get. So it's 60 times 1000 times 5000 divided by 765.8 times 6.4. So 61210. So 61210 MPa. This is the value of E. So it is slightly less value, but this is what we get from the calculation. Now we can we can directly calculate the buckling load. It is straightforward. Everything we have now. Now P is given by pi square EI upon LE square. Now E is known. We have to calculate the value of I. So let's just calculate that. So I is given by pi by 64 times capital D is 40 raised to 4 minus 25 raised to 4. Okay, so this comes out to be, so just calculate this also first. So pi upon 64 times 40 raised to 4 minus 25 raised to 4. So it is 104850. 104851. 104851 mm to the power 4. That is the unit of I. So this is nothing but pi square into E value we have 61210 times. We have the value of I here 104851 divided by effective length is 5 meters, that is 5000 squared. So we'll quickly calculate this. So we have the answer here. So answer is I. So it is shift pi square times 61210 times answer. Answer is nothing but I stored in the calculator, 5000 square. So this gives me 2533 Newton. So it's very small value, 2533 Newton, or it is 2.53 kilonewton. So it's a very small value because the value of E is relatively very small. Okay. So I hope this question is clear. This is all we have to do for 10 marks. It's very fast. We can solve this problem. I hope this is clear. Don't get confused seeing this, why E is not given. You can calculate E using the basic formula from module 1. So that's it. I think we can end this video here. Now we will meet each other in the next video where I'll be solving another KTU problem. Thank you.